right, guys, all right. I forgot to bring my iPad today. Oops, I forgot to turn on the light to this. Let me turn this on. Okay, let's stand up, let's stand up. I forgot to bring an iPad, so I'm filming with my camera that's on the other chalkboard's ledge. So I have no idea what this is going to look like. I'm going to go to try to record the Zoom part on speaker view, but it wasn't working before. So I'm going to see if it works this time. I'm going to come up here, go to active speaker. See, right now, all I'm seeing is Lindsay. Lindsay's mic is off. And I am speaking directly into the microphone here, but it's not picking up me as the speaker. So I think I'm going to have to just go back to grid view. Okay. Well, we'll figure her out. We are going to have a quest. Next Wednesday. Okay? And it'll be over tangent lines, some stuff with our limits, the limit definition of derivative, and I'll be a little more specific on Friday. But we're going to have our next quest when? Wednesday. Some of you guys will be taking it in class. And other people will be taking it online. Some of you will be taking it in class, and other people will be taking it online. It will be all handwritten. No webassign. So everybody will be taking the same thing. Some will be taking it
online and in class.
Online and in class. We'll be going back to our 8A Z day. And again, I'll talk more about that on Friday. Okay, stand up. I want to get your brains going. Stretch. Okay, let's sit back down. If you can turn on your video, turn on your video. I want to get your brains going. Write down the limit definition for f prime of 4. So at your seats, write down the limit definition for f prime of 4. Okay. Hopefully you're done. Okay. F prime of 4 is equal to, you help me out. F prime of 4 is equal to the
1 minus x squared 4.
Of minus f of 4 all divided by x minus 4. Okay, now here's the thing, guys. If you're working with data and you're trying to get a derivative and you're working with data, you're not going to be able to take a limit because you're dealing with data. So what you have to do is you have to use an approximation. You're taking the next closest data point to the point 4 f of 4, and then you set up essentially the slope. Like, for example, maybe you had some information at the point 5 f of 5. And then your approximation to the derivative for f prime of 4, it would be approximately equal to f of 5 minus f of 4 all over 5 minus 4. And so we're going to use this idea to help us develop derivative tools. we're going to use this approximation idea to help develop two of the most important derivative tools today. And they're going to free us from the limit definition of derivative. Are you ready to do that? Are you ready to do that? Okay, so I'm erasing this. And I'm saying if x is close to 4, and that's approximately, that's the approximation sign. Just two wiggly lines, two wiggly lines. If x is close to 4, we're looking at the limit as x approaches 4. So maybe here's 4, and x is really close to 4. Well, this would imply then that f prime of 4 is really close, is approximately equal to this fraction. That f prime of 4 is approximately equal to f of x minus f of 4 divided by x minus 4. Now imagine you had this. Banana minus 2 over 7 equals 8. Banana minus 2 over 7 equals 8. Could you solve for banana? Could you get banana all by itself? Go do that. Go do that. Go find what banana is. If banana minus 2 over 7 equals 8, find banana. And does anybody have a banana? Does anybody have a banana? What do you have for your banana? What's the banana? What do you have for a banana? 58. 58. How many people got 58? How many people got 58? Okay, you're like, Dr. Warren, this is calculus. What are you doing? Okay, how did you get 58? What was your first move? How did you get 58? What was your first move? Multiply both sides by 7. And then what did you do to get banana all by itself? Add 2. We're going to be doing the same algebra. We're going to be doing the same algebra with this. Instead of banana, I'm going to be getting f of x all by itself. The 2 is being played by the f of 4. The 8 is being played by f prime of 4. And the 7 is being played by x minus 4. So this is the algebra that we're going to do. We're going to multiply both sides by 7, which is the x minus 4. And if I did that, I would have f prime of 4 times x minus 4. Now it's not an equal to, but it's kind of, is approximately equal to f of x minus f of 4. And that's the first thing you guys did here. You multiplied both times by 7. Now I want to get f of x all by itself. What would I do if I wanted to get f of x all by itself? What would you do to both sides if you wanted to get f of x all by itself at that point? Add f of 4. We're going to add an f of 4 to this side, and we're going to add an f of 4 to this side. And so this is just another way of working the derivative. It's not exact. The limit form is exact. This is just another way of working the derivative. And so what we're going to do is we're going to write this down again and put it in a box. If f prime of 4 is equal to this limit, then that would imply that, and I guess maybe I'll put it down here, that if x is approximately equal to 4, this implies that f of x is approximately equal to f prime of 4 times x minus 4, that's this guy, f prime of 4 times x minus 4 plus f of 4. And let's just put this into a box, because we're going to be using this a lot today. Can I erase this, guys? Can I erase that? Not yet, not yet. Okay, I'll do these. Okay, similarly, as some of you guys are writing that down, similarly, what would the definition of G prime of 4 be? What would the definition of G prime of 4 be? What would the definition, Dr. Warren, you gotta quit beating me with this. What would the definition of G prime of 4 be? La 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 la.
Well, as x approaches over g of x minus g of 4 over x minus 4.
Over x minus 4. It's the same thing, same thing. It doesn't matter what function I pick. Could we play the same game that we were just playing? Could we play the exact same game, except that now instead of having an f, we have a g? Could we play that exact same game? So let's do that, but let's not do it. Let's just say we did it. Let's not actually do the work. If I did that, then also in a box I could put that g of x would approximately be equal to g of x, and you guys fill in the rest. G of x would approximately be equal to what? If we did the exact same thing we were doing over here, but instead we worked with that. You write down what would go in that box. Okay, now you're going to go to grid view, you're going to go to breakout rooms, and you're going to share what you've got with somebody else. You're going to share what you've got with somebody else. I'm so angry that it doesn't do that. Okay, I'm playing singles. I'm going to pick on, let me see here, Thomas, man. Thomas, what do you have for me here? What do you have for me for the g of x?
I have g of x equals g prime of 4, g minus 4 plus g of 4.
Let's do x minus 4 instead of g minus 4 and x minus 4 there.
Okay, yeah.
Oh, and then plus what?
Plus g of 4.
G of 4. Excellent. Let's give it up for Thomas. Come on. Put those hands together. Let's give it up for Thomas. Okay, now this is not an equal to, but an approximately equal to. But we're kind of thinking of it like an equal to. How many people are following? How many people are with me so far? Okay, now it gets hard. So focus. Stand up, stand up, stand up. This is one of the most important results we're deriving all semester. Grab your magic lasso. Grab your magic lasso. Grab your magic lasso. Grab your magic lasso. Throw your magic lasso. Throw your magic lasso. Wrap it around your head. Wrap it around your head. Wrap up your attention span. Wrap up your attention span. Wrap up that little piggy. Wrap it up. Now sit back down. Sit back down. I need you to focus. Here we go. Imagine that we have two functions. One's cleverly called f, and one's cleverly called g. And I'm going to create a third function by multiplying those two functions together. Now what we're developing, guys, is this thing we're going to call product rule for derivatives. What we're developing is this thing called product rule for derivatives. H of x is equal to f of x times g of x. The actual definition, the limit definition of derivative would say, well, h prime of 4 is equal to, just like here and just like there, by definition, h prime of 4 would be equal to what by definition? La 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 la. La 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 la.
The limit as x approaches 4 equals h.
Good, good, good. You're going. Keep going. H of
minus h of 4 over x minus 4.
exactly h of x minus h. Is it Lorelei? Is that right? Is that Lorelei right?
Yeah.
Okay, Lorelei's exactly right. Here's my function h of x. Okay, here's h prime of 4. Well, by definition, it's h of x minus h of 4. Now, come up here. Look at this. What would h of 2 be equal to? What would h of 2 be equal to? If h of x for any value of x is equal to f of x times g of x, what would h of 2 be equal to? Yeah, Dr. 1, the number? No, not the number, just an expression. What would h of 2 be equal to?
F of 2 times G of 2.
Yeah, just f of 2 times g of 2. F of 2 times g of 2. How about h of lollipop? What would h of lollipop be equal to? What would h of lollipop be equal to if h of x is equal to f of x times g of x? What would h of lollipop be equal to?
F of lollipop times g of lollipop.
Perfect. F of lollipop times g of lollipop. Okay, how about h of cigarette lighter? How about h of cigarette lighter? What would h of cigarette lighter be equal to? What would h of cigarette lighter be equal to?
F of cigarette lighter times g of cigarette lighter.
F of cigarette lighter times g of cigarette lighter. Now look at the numerators. Look at the numerator back here in our limit definition. What would h of 4 be equal to? What would h of 4 be equal to? And then what would h of x be equal to? Substitute them in. Substitute them in this next line of logic. I'll start us off. But then this would mean h prime of x would be equal to, and I'll help you out. I put an x minus 4 there. You get the right, you put in the things that go in the numerator. You write down what you think you can write in the numerator if you know that h of x is equal to f of x times g of x. If h of x is the product of those two functions, what could you put in for this dude, and what could you put in for that gal? I guess gal isn't a word anymore. Okay, go to grid view, 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 go to grid view. Hold up what you got. Hold up what you got. I want to see what you all have. Hold up what you have in that line. This is important. What do you have in that line? Let me see what you guys have. Hold up what you have. Some of you aren't holding up anything, and you can see you're not holding up anything. If you got nothing, hold it up. Lainey, hold it up a little closer for me to see it there. And hold it still. Oh, sorry, Lainey, the feed isn't good enough here. Well, let's see. Trey, what do you got there? Trey, I like your starting off great, Trey. What do you got there, Zach? Zach, hold it up for me, man. Let me see what you've got.
I don't know the answer, so.
You don't know the answer. Okay. Jonathan, what do you got? What do you got for me, Jonathan?
The limit as x approaches 4, f of x times g of x over x minus 4.
I like a lot of that. I like a lot of that. I see where we're heading. Make me number 1. Make me number 1. Okay. If I look at that minus sign, it's just going to go right there. It's just going to go right there. Then this minus sign is the same as that minus sign. Now you said, Dr. Warren, h of 2 is f of 2 g of 2. Cigarette lighter. H of cigarette lighter, F of cigarette lighter, G of cigarette lighter. What would H of 4 be? What would H of 4 be? Using the same kind of logic, what would H of 4 be?
F of 4, G of 4.
F of 4, G of 4. Now how about H of X? How about H of X? What could I substitute in for H of X? And this is where some of you guys already had this. What could you substitute in for that person?
F of X, G of X.
F of X, G of X. So get those down. Get those down. Get those written down properly. Okay, now we're going to use the box. Now we're going to use our boxes. Let's suppose that X is not quite 4, but X is approximately 4. X is not quite 4, but X is approximately 4. Well, then H prime of 4 would be approximately equal to what's here. H prime of 4 would be approximately equal to what's here, which is F of X times G of X minus F of 4 times G of 4 all over X minus 4. And you're like, okay, doctor, when I get that, I mean, I kind of agree. Sure, this is equal to this. This is equal to this. If it's close, then it's approximately equal to that. Get rid of cigarette lighters. Okay, how many people are following so far? How many people are following? This is one of the toughest arguments we have to make. This is one of the toughest arguments we have to make. But since F prime of 4 exists and G prime of 4 over here existed, we're assuming that F prime of 4 exists and G prime of 4 exists, then F of X, if X is approximately equal to 4, F of X can be replaced with F prime of 4 times X minus 4 plus F of 4. And G of X can be replaced with G prime of 4 times X minus 4 times G of 4. Now we're going to do that and we're going to write really big. What did I say?
We're going to write really big.
We're going to write really big. I'm going up to this board right here. This would imply, logically imply, that H prime of 4, now don't yell at me. Write a big fraction. Write a big fraction. A big fraction. This denominator is going to go right in the center. X minus 4. This minus sign right here is going way, way over here. This minus sign is going way, way over there. And then I'm just going to write down F of 4, G of 4. This is going to be the F of X location, and that's going to be the G of X location. Okay, now what I want you to do is I want you to replace F of X with this stuff on the right. F of X is approximately equal to this right-hand side. Put that right here. And similarly, G of X is approximately equal to this stuff. Put that right there. So you're replacing F of X with all of this, and G of X with all of that. So write that down. You guys write it down. It's going to be easier if you put it in from your notes than trying to see it over Zoom. Okay, as you write, I'm gonna fill in. As you write, I'm gonna fill in. What would I put here, guys? What would I put here? You guys help me out. What would I put there? What would I put there?
F of 4 times x minus 4 plus
F of 4.
F of 4, perfect. F prime of 4 times x minus 4 plus f of 4. That's just from there. And what would I write here? What would I write in this? What would I write in that parentheses?
G prime of 4 times x minus 4 plus G of 4.
Okay, so that's in here. And then I've got the minus sign, I've got this minus sign, and then I've got my f of 4 and g of 4. How many people are with me so far? How many people are with me so far in this argument? Okay, now we've got to go back to algebra. If you had, this has nothing to do with this problem. What did I say?
This has nothing to do
I'm making this up out of thin air. But if you had 2x plus 3 times 5x minus 7, if you had this binomial times this binomial, could you multiply those together correctly? Could you guys, do you guys remember how to multiply these together? Do you remember this thing? FOIL, do you remember that? FOIL, I don't know if they teach it anymore. FOIL, first, outer, inner, last. First, you multiply those together, then the outers together, then the inners together, and the last. We're going to do the same thing, but it's going to be far more complicated. This is going to be the first term, so that's kind of like in the 2x location. This is going to be the second term, that's kind of in the 3 location. This g prime of 4x minus 4 is kind of like this guy, and this plus g of 4 is kind of like the minus 7. But guys, all we're going to do is FOIL. It's just foiling. But you've got to focus or you're going to mess it up. You've got to focus or you're going to mess it up. Okay, draw a bigger fraction. Draw a bigger fraction. Put x minus 4 in the middle of the denominator. And we'll just put it equal to here. This is going to be equal to this. Put this guy over here, minus f of 4, g of 4. I'm not worried about this guy at all. I'm not dealing with this dude at all. Remember you grabbed your magic lasso and wrapped up your, what did you wrap up? Or we've already forgotten. What did we wrap up when we grabbed our magic lasso? The attention span. Some of you are like, oh, Dr. Wayne, I forgot. Stand up. I can already tell you need it. We're halfway through Vietnam, and you already need a break. You need to be sent home side. Stretch. Okay, sit back down. I have a buddy who's a professor here who was in the Peace Corps. And he was saying that one thing that they would do in the Peace Corps when somebody would kind of lose it, because they're really in some pretty hostile situations, they called it wacko-vac. If somebody went wacko, like in Africa on their Peace Corps duty, they wacko-vac them, meaning they send in a transport plane to pick the person up and take them back to the States so they could get their mind right. Well, there was one person serving, one of his female friends was serving in a certain African village that had no running water whatsoever, and had no toilets. So what the village did is they dug a 30-foot deep pit and put two 16-foot boards over the pit. And so people would go to the bathroom standing or squatting on the boards. She got up in the middle of the night to go to the bathroom, was going to the bathroom, and one of the boards broke. And she fell into the pit and was there until morning. She was wacko-vac. Okay? She was wacko-vac and never returned to Africa. Okay, and that's where you guys feel right now. You're like, Dr. Warren, I'm kind of feeling like that board's going to break. I'm sitting on the toilet right now. I don't know where we're going with this. We're proving product rule. If you have two functions, how do you take the derivative of the product of two functions? Okay. And we're here. We're now going to FOIL. I'm going to help you. I would have this first term, f prime of 4 times x minus 4, times this first term, g prime of 4 times x minus 4. So this would become f prime of 4 times g prime of 4 times x minus 4 squared. How many people can see that? How many people can see that? If I multiply this term times this term, I would get the f prime of 4, g prime of 4, and the x minus 4 squared. Okay, the next thing I'm going to do is the outers. The next thing I'm going to do is the outers, which is this term and this term, which is this term and that term. You write down what the outers will give you. You watched me write down what the first would give you. You write down what the outers will give you. And does anybody have what the outers would give me? What would you have if you multiplied that term times that term? What would you guys have? Let me get down here. What would you have? Anyone?
I think it's f prime of 4 times g of 4 times x minus 4.
Perfect. Who was that? Who was that? Who was that? Alex? Thanks, Alex. Let's give it up for Alex. Come on, let's give it. You're not in grid view, so Alex, you can't see everybody clapping, but I can. They're all clapping for you except Kelly. Kelly's not clapping. Kelly, clap. Thank you, Kelly. Okay. Okay, now, let's do the inners. Let's do the inners. You guys do the inners and write down. You just watch Alex, what she did with the outers. You do the inners. Alrighty. Che, what do you got for me, buddy? What do you got for me when you do the inners?
F of 4 times g prime of 4 times x minus 4.
Perfect. Times x minus 4. So I've got f of 4 times g prime of 4 times x minus 4. That only leaves the what in the FOIL? What's the only thing we have to do in the FOIL now? The last. So let's look at the last terms. I've got this term times that term. And when I do that, I would get a plus what? And when I get this term times that term, what would I get, guys, if I multiply those two together? F of 4 times g of 4. And you're like, Dr. Warren, this is a lot of work. You started over here, which h of x equals f of x times g of x. You're getting wacko act right now. You guys are getting wacko act, okay? We have h prime of 4, we use the limit definition. Then we just substituted in what these things were. Then we used our approximation game. We substituted in from our approximation game, and then we FOILed. So it's not really that much. There's just a lot of stuff on the board. Now, what do we notice about this guy and this guy? What do we notice about this guy and this guy? What do you notice about f of 4, g of 4, and minus f of 4, g of 4?
You can combine like terms.
Yeah, they kill each other. They go away. Now there's an x minus 4 here, there's an x minus 4 here, there's an x minus 4 here, and we have abundance. We have an abundance of x minus 4s here. Is there enough to kill a Gary Dreibelbis? Can we get rid of Gary Dreibelbis algebraically? Is there enough to get rid of the x minus 4? Could I remove it from all of these terms? Could I remove it from all of those terms? And that's what we're going to do. This would be equal to, you guys are going to help me. I could factor an x minus 4 out of this. I'm not going to do it. I'm not going to do it. I could factor an x minus 4 out of this. I'm not going to do it. And I could factor an x minus 4 out of this. And these two guys are gone. That's a 0. That's a 0. If I did that, I would be left with f prime of 4 times g prime of 4 times not x minus 4 squared, but just an x minus 4. Only an x minus 4. The second term would just be f prime of 4 times g of 4, because one of these would cancel. And then I'd be left with f of 4 times g prime of 4. That's where this guy has canceled that, and one of those. It's canceled that, and one of those, and these two guys are gone. Do things look better? Do things look better? Che, do things look better? And you're like, well, Dr. Warren, yeah, this doesn't look as complicated. This doesn't look as complicated. Okay, this is where it gets really beautiful. We started off with x being, just read that. Can you read that? That says what? That says what? X is approximately 4. And this is the limit as x goes to. This is the limit as x goes to 4. Well, if x is approximately 4, or we're taking the limit as x approaches 4 to get my derivative, what happens to this term? What happens to that guy as x gets closer and closer and closer to 4? What happens to this term as x gets increasingly closer to 4? What does it go to?
0.
0. And what's 0 times any real number? What's 0 times any real number?
0.
0. So in the limit, h prime of 4, in the limit, it's not an approximation, it's an equality. This was an approximation because x was approximately 4. But in the limit, this term goes away, and we're left with f prime of 4, g of 4, plus f of 4 times g prime of 4. And that's the result we've been trying to get. That's the result we've been trying to get. Okay, stand up. You need a break. Stand up. You need a break. We are so close, guys. This result is going to give us so much. Okay, sit back down, sit back down.
Dr. Warren, could you read that last line again?
This one right here.
Yeah.
Okay, yeah, Alex, it's h prime of 4 equals f prime of 4 times g of 4 plus f of 4 times g prime of 4. Do you guys all have that? Do you guys have that? I'm so sorry you have to do this over Zoom.
Thank you.
Like, do you want me to keep, like, guys, when we go to A Day and Z Day, after October 5th, I'm just asking a question. Do you still want me to do the Zoom? Would it still be good for you? If you guys, if you're on a, let's suppose the A Dayers are here and it's a Z Day, would you still want to come to class for Zoom? Would you still want to Zoom in with the other people being in the room? Or would you rather go back to where I just made a video of it, the lecture, and then put that up? Which would you rather do? Would you rather see it live, or would you rather?
Live.
Yeah, I did not Zoom.
Live? Okay. Then I'll keep doing it, and I'll keep making iPad videos, and I don't know what else I can do I mean, I guess I could bring a pony in. We could have a pony rides in here. I think that would be probably fun. Trey's like, yeah, let's do pony rides. One professor here, doesn't work here anymore. One professor gave a final in the village, gave a final at the picnic tables in the village, and brought a pony that he was having for his daughter's birthday, and rode his kids around on the pony while the kids took the finals at the picnic table. Is that not the most surreal thing ever? You're like, that didn't really happen. No, he brought a pony into the village, rode his kids around the students while they took their final. No. Okay. Oh, I've got to get rid of this. Dr. One, what do we show? And now you won't listen at all. Doesn't matter what I say. It's been 40 minutes. You're like, I'm done, Dr. One. If the function h of x is equal to, if the function h of x is equal to,
f of x times g of x.
then h prime of 4 we justified was equal to, and this is what Alex had me write down, is equal to
f
F prime of 4 times g of 4 plus f of 4 times g times g prime of 4.
Now, Hansel and Gretel, my little Hansels and Gretels, how important was the 4? Suppose it was not a 4, but it was a 7. What do you think we could show h prime of 7 was the equal to? If we did it all over again, which we are not, what do you think we could show h prime of 7 would be equal to?
f prime of 7 times g of 7 plus f of 7 times g prime of 7.
Very good, parents. Now I'm going to erase my approximations.
Dr. Warren, this was the longest way I've ever seen product rule explained.
Yeah, I know, but it's the way that I can hold on to most students. Most students just get buried when you do this little trick of adding 0, subtracting 0. They just don't get it. We will now continue. How about if it was h prime of, what's your favorite drink? What's your favorite drink?
Root beer.
Root beer. What if it was h prime of Snapple root beer? What if it was h prime of Snapple root beer? What would that be equal to? What would that be equal to? What would that be equal to? H prime of Snapple root beer would be equal to,
f prime of root beer times.
you're like, Dr. Warren, why did you pick root beer?
Plus f of root beer times root beer.
Dr. Warren, I'm not writing down the root beer. Okay, don't. So no matter what you put in here, you're just putting it on the other side. I don't care what the number is that you're putting in. Let's just say it was h prime of c, for any real number c. H prime of c would be equal to, that's a little bit easier for you to write. H prime of c would be equal to,
F prime of c times g of c plus f of c times g prime of c.
and you see what you don't got is what you don't realize is every time you're writing this down, I'm writing it on your brain. Wax on, wax off. I am Mr. Miyagi. I am Mr. Miyagi. Wax on. Now, x is just a variable, guys. X is just a variable. If it's a real number, h prime of x would be equal to, h prime of x would be equal to, h prime for any value of x would be equal to, h prime for any value of x would be equal to, just look here, h prime of x would be equal to
x times g of x plus f of x times g prime of x.
f prime of x times g of x plus f of x times g prime of x. But h of x was equal to, in the beginning, h of x was equal to f of x times
G.
g of x. So the derivative of h of x, which is this, is the same thing as saying, by substitution, the derivative of f of x times g of x. And this is equal to f prime of x times g of x plus f of x times g prime of x. And this is our most important flashcard of the semester. This is our most important flashcard of the semester. It's not what we thought it would be. It's not what we thought it would be. We thought it would be, we really thought, I mean, when you first see f times g, what would you guess? What would most 8th graders guess the derivative of f times g to be? If they had to guess, what do you think most 8th graders would guess? Like Dr. Warren, they don't even know what the hell a derivative is. But if you ask them, what's the derivative of f times g? Guess what most of them are going to say? They'll be like, it's f prime times g prime. And I have students do that all the time. Oh, it's just the derivative of this guy times that guy. No, it's not. It's not. There's a plus sign. There's a plus sign in it. You're like, there's a plus sign? There's a plus sign. It's the derivative of the first. Say that.
The derivative of the first
Derivative of the first
Times the second.
times
the second
f.
Plus the first.
plus the first
Times the derivative of the second.
times the derivative of the second.
Okay, now we're going to say that again, choir. Are you ready? What's the derivative of f times g? The derivative of f times g is the derivative of first times the
second plus
the
the
first times the derivative of the second. Close your eyes. Close your eyes. Look at nothing. Close your eyes. Look at nothing. Product rule. What's the derivative of f times g? Go. Oh, I can't wait till Monday. I will hear you. I hear nothing now because I didn't have you put your hands on the spacebar. What's the derivative of f times g? Derivative of f times, derivative of f times, derivative of f
G
times,
of x times f of x times g prime of x.
f prime of x times g of x plus f prime of x times g of x plus f of x times g prime of x. Oh boy, guys, we just got three. We just got three. This rule and one more rule, the sum rule, which falls so much easier. The sum rule, which falls so much easier. But we have product rule. We have product rule in the game. I'm going to see if you guys remember anything that I taught you on Monday. We're ending with this. We're ending with this. Our first flashcard. First derivative flashcard. Don't say it. Don't say it. Second derivative flashcard. What's the derivative of function x, and what's the derivative of a constant? What's the derivative of a function x? Now say it, say it. What's the derivative of x? Your number 1. What's the derivative of a constant?
0.
0. And then our last one, the one we did today, the toughest one, what's the derivative of a function times a function? Okay. All right, you guys were good, you guys were good. Okay, I would say we only were down in that latrine a little bit. We were only down in the latrine before we got back out, before we got back. Could you imagine spending the night? I would be a basket case for the rest of my life. If I was down in the latrine full of just crap and urine for hour after hour, wondering if they'll ever find me, yeah, I would be done. I would be done. You want to join the Peace Corps? You want to join the Peace Corps? No, just kidding. Join the Peace Corps. Join the Peace Corps. It's good. Okay, okay. I will see you on. When do we have our next quest? When do we have our next quest?
Next Wednesday.
Next Wednesday. Next Wednesday.
Thank you.
Thank you guys.
Thank you. You have a good one.
Hey, Dr. Warren.
Yeah.
I have a question about the 8A Z Day. So I think I'm a Z Day. So if like we're supposed to go to class, are we allowed to like attend the Zoom? Like if I'm like
Oh, yeah, Brad. If if you're on the off days, my goal is I'd have half my kids here and everybody else zooming in.
Yeah. Well, no, like I love being in class and all, but I feel like I'm learning like a lot from Zoom too. But like obviously when we're allowed to go in person, like I'll come. I'm just saying like, do we have the option?
Yeah, you could still, like if you're not feeling well, I don't want you in class, for sure.
All right. Thank
You
you
know,
so much.
but I do think like right now I'm kind of a fisheye thing.
Yeah.
And so like when you're here, it's just so much easier. And then if I say, oh, share what you have with somebody else, right now I've got to go to breakout rooms and you can barely see each other. You know, we're here, you just like, okay, and Paris is there and
Yes.
okay.
All right. Yep. Thank you so much.
Oh,
Have a
thank
nice
you,
day.
Brad. My phone, I forgot my. Oh.